There's a girl jumping on a trampoline. Imagine the trampoline to be down here. The girl's bouncing up. I'm going to abstract the girl as just a rectangle. On her way up, she reaches out and grabs a box. In fact, I'm going to abstract the rectangular girl as just a dot now, and the mass is just a point particle too. The girl has a mass, say, of, I'm going to call her M1. The box I'm going to call M2. We're going to say she jumps up to some height here, where she grabs a box. She started down here. She started with an initial velocity, which we know, coming up off of the trampoline surface. And she reaches a height, which we know. And we know the mass of her. And we know the mass of the box. So all of these things we know. And the first question, part A, is what's her speed? What's the velocity or the speed upwards just before she grabs the box? Well, you can use kinematics to calculate how somebody with an initial speed going upwards, starting at, say, if we call this our y-axis, where this is positive and upward is positive, we're starting right here at 0. So it's just a kinematics question as to, given that you start off with an initial velocity going upwards, how fast are you going just when you reach a certain height? You also could use energy arguments, but let's say kinematics, let's see, these are differences in height, so we could use y final is equal to y initial plus velocity initial delta t plus 1/2 a delta t squared. But I actually think maybe that's not the best one. How about this one? Velocity final squared is equal to velocity initial squared plus 2a d delta x or delta y. I like that one. Our final velocity is what we want. Our final velocity is what we want to solve for. Our initial velocity we have. Our acceleration we have. Remember, its acceleration is constant due to gravity. It's downwards at 9.8. So here, acceleration is going to be negative 9.8 meters per second squared. Delta y, final minus initial, is going to be RH. So you can calculate in this case, the final velocity is what they call in the question the velocity just before the girl grabs the box on her way up. So this would be velocity before all squared. So you can calculate velocity before now. And this one would be annoying because you'd end up with a quadratic. So now you know the velocity just based on kinematics, given the acceleration, her initial velocity, and how high she went up, how fast she'll be going upwards just before she catches the box at height h. So part B is what's the speed of the girl immediately after she grabs the box? Well, notice kinematics is, well, it doesn't deal with situations like that easily. We're going to use momentum. What that means, conservation of momentum says the momentum doesn't change. Whatever momentum there was before is the momentum there is afterwards. And so momentum before was all held in the girl. because the momentum of this box was 0 because it wasn't moving. So the momentum before is equal to the mass of the girl, which was m1, times the velocity of the girl. Velocity before, we just calculated it. So now we know what the momentum is, and that is the momentum that's going to be carried further up by her and the box together. The momentum after is going to be equal to her plus the box moving with some velocity after, which we don't know. But we know everything else. These two momentums, there's no change between them, so they equal each other. So you can calculate her velocity after. It's going to be lower. A smaller mass traveling quickly has the same momentum as a larger combined mass traveling slower. So we expect her to grab that box and immediately slow down. So now here she is. I'm going to assume, so at just a millimeter above h, so basically at h, she now has a second velocity. The moment after she grabs the box, she has the velocity after. That's continuing to take her upwards, but slower. Part C, part D, what's the maximum height the girl reaches? I think you can use kinematics again. I think you can use this same equation to calculate this delta y. So in this case, our velocity final squared is equal to velocity initial squared plus 2a delta y. Velocity final at the top of her arc, she's going to go up a little bit further, right to there. Her velocity at the top of an arc is 0. Her initial velocity is going to be this velocity after that we've just calculated. Acceleration, remember it's negative 9.8. And this delta y, you can calculate, but just remember, the delta y you calculate is just this distance here. That's the delta y you calculate. If you want to figure out what the maximum height is, you better add on the height that she started from, because this kinematic equation just covers this little region of space here, not the events before she grabbed the box. Yeah, so you should be able to calculate. That was part D.